Welcome to Spring LIB.
Our question says that the United States National Electric Code sets maximum safety currents for insulated copper wires of various diameters. It is given in part in the table, and it wants us to plot the safe current density as a function of diameter. And it wants to know which wire gauge has the maximum safe current density. And as an aside, gauge is a way of identifying wire diameter, and 1 mil is equal to 10 to the minus 3 inches. So I'd write down that's what we're given here. 1 mil is 10 to the minus 3 inches. Okay. And we can express the magnitude of current density vector in SI units by converting the diameter value in mils to inches with that conversion. And then to put it in SI units, we can convert it from inches to meters. So let's write down what that conversion is as well. So 1 inch is equal to 0.025 meters. Okay, and we can also use the fact that the current density here, J, is equal to the current divided by the area, which is equal to the current divided by pi r squared. Now let's write a better pi here. Okay, which is equal to 4 times I divided by pi times the diameter squared. So now we have a relationship between the current density and the diameter. So for example, the gauge 14 wire has a diameter of 64 mils. And using the conversion above, diameter for is 64 mils, which using the conversion above is equal to 0.0016 meters. And I got that by dividing 64 mils by 1,000 inches and then multiplying that by 0.025 meters. Okay. And then we can plot the values of J in SI units versus their diameter in mils. We'll plot that over here. And it looks something like this. It comes up, it peaks, and it starts to drop. Where this axis is the diameter, J, in mils, and this, is the current density, J, in amperes per meter squared. And then this is the diameter, D, in mils. Okay, so we'll write ampere per meter squared as the units, and mils as the units for this. Okay. Now the scale on this graph we have here is about 4 times 10 to the 6, which can just be written as E plus 6, all the way up to here, which is about 7 times 10 to the 6. So 7 times E plus 6. And the scale here starts at about 40. The peak here is around 65. So we can use that gauge 4 wire there, since the gauge 4, not gauge 4, gauge 14 wire was found to have a diameter of 64 mils. So that gauge 4 wire will give us our maximum current. And it goes up to about 200 over here. Okay, so judging based upon the graph, the maximum safe current density is found from that gauge 14 wire with a diameter of 64 mils and has a maximum current density, we'll write J, which equals 7.2 times 10 to the 6 amperes per meter squared. Okay, so we were able to plot the safe current density as a function of diameter, and we were able to show which gauge has the maximum safe current density. It's the gauge 14. So we can also write here for gauge 14. All right, we can box all of that in as our solution, as well as this graph over here.